Hi, welcome to Algebra 2 Common Core. We're going to look in Lesson 4 at adding probabilities. I want you to draw a picture of this Venn diagram in your notes so that you can refer to it. The general probability law for adding. When I want to find the probability of something occurring in A or B, what we're going to have to do is count all of the ways that it can occur in A, count all of the ways that it can occur in B, add those together, but then subtract the ones that we have counted twice, the ones that fall in the intersection, the probability of A and B. So you'll see that all of the following problems can be done using this general probability law. Let's take a look at number 1. If we have a standard deck of 52 cards and we want to find the probability of having a red card or a face card, I'm going to set up the law by saying the probability of red or face is going to be equal to the probability of red plus the probability of a face card minus the probability of having a red card that is a face card. So, to get the probability of red or face, the probability of red, well, half of the cards in the deck are red. Another way of saying that would be 26 of them out of 52. Plus, face cards, there's a jack, a queen, and a king of diamonds, of hearts, of spades, and of clubs. So there are 12 face cards in the deck out of 52 cards. So we're going to add on 12 out of 52. But then we have to count how many of them are red cards that are also face cards. So we have the jack, the queen, the king of hearts, also the jack, the queen, and the king of diamonds. So we're going to subtract 6 out of 52 because we've counted those twice. So go ahead and do that subtraction and we end up with a total of 32 out of 52 cards. And again, it's okay to simplify, but you're not required to. So in simplified form, this would be 8 out of 13 by dividing the numerator and denominator by 4. Let's look at example number 2. Given the 2 dice are rolled, let's find the probability of getting an even sum or a sum less than 5. So if we write this, given our rule, we're going to say the probability of an even sum or a sum less than 5 is going to be equal to the probability of an even sum plus the probability of a sum less than 5 minus the probability of having an even sum that's less than 5. Now it's going to take a little bit to count up how many we have in each category. If I'm trying to get an even sum when I roll 2 die, that means that I've got to have something like a 1 and a 1, a 1 and a 3, a 1 and a 5, a 3 and a 1, a 3 and a 3, a 3 and a 5, a 5 and a 1, a 5 and a 3, a 5 and a 5. So 2 odds add together to give me even, but I can also get an even if I add 2 evens together. So 2 and 2, 2 and 4, 2 and 6, 4 and 2, 4 and 4, 4 and 6, 6 and 2, 6 and 4, 6 and 6. So altogether, there seem to be 18 of the sums that are even sums. We've used up half of the numbers that we could possibly add together, so it's going to be 18 out of 36. Plus, the sum less than 5, let's count them. 1 with 1, 1 with 2, 1 with 3, that's 3 of them. 2 with 1, 2 with 2, or 3 with 1. So there happen to be 6 of them that have a sum less than 5, so 6 out of those 36 sums. Minus the even sums that are less than 5, 1 and 1, 1 and 3, 3 and 1. So subtract 3 out of 36. When we add and then subtract, we're getting a total of 21 over 36, and that reduces to 7 out of 12. In example number 3, we're looking at an insurance company. They have different policies. At one company, 56% of the customers have car insurance policies. So I'm going to write down what we know. The probability of car insurance is equal to 56%. 48% have home insurance policies, so the probability of home insurance policies would be 0.48. And 18% have both. So the probability of car and home, that's equal to 0.18. So the first question says, find the probability that she or he has at least one of the policies. So that would be the same thing as saying, let's find the probability that they have either car or home, because then we're counting both as well. So that's going to be the probability of car plus the probability of home minus the probability of both, because we want to subtract out the ones that we've counted twice. So that's going to give us a 0.56 plus 0.48 minus 0.18. So my total here is going to be 0.86 for customers that have at least one of the policies. And again, if you think about our Venn diagram, at least one of the policies is going to be all of the ones that are included in the two circles. So home insurance, car insurance, it'll be this circle, and only count the intersection once. Now, for the second half of the question, it says find the probability that she or he has neither of the policies. Well, neither of the policies means on my Venn diagram, we're talking about the people that are outside of the two circles. So neither is going to be the probability of C or H, but then we're going to subtract that from 1 because we have to take the complement. We want the ones outside of those two circles. So in this case, we're going to say 1 minus 0.86, and that's giving me a probability of 0.14. So notice that our two answers this time are complements of each other because they add to 1. In example number 4, it says that a high school has a population of 1,376 students. The number of students who participate in sports is 649. The number of students who participate in music is 433. And if the probability that a student participates in either sports or music is 974 over 1376, what's the probability that a student participates in both sports and music? So let's go ahead and write down our givens. So we know that the number of students who participate in sports is 649, so the probability of a random student participating in sports will be 649 out of 1376. The probability that a student participates in music will be 433 out of 1376. And we know that the probability of them participating in sports or music is given to us as 974 out of 1376. So if I set up my equation, the probability of sports or music would be equal to the probability of sports plus the probability of music minus the probability of sports and music. Now in this example, we want to find the probability that a student participates in both. So we're actually looking for this in my equation. Let's fill in what we know into the equation. So we know that the OR is going to be 974 over 1376. The probability of sports is going to be 649 over 1376. And the probability of music is 433 out of 1376. But then this is what we're looking for, the probability of S and M. Now we're just going to treat this as our unknown, so we want to get that quantity by itself on one side of the equation. So isolate this. Because it's got a minus, I think I'm going to add it over to the left side of the equation. And at the same time, let's take this answer and subtract it over to the right side of the equation. So the probability of S and M would be equal to 649 over 1376 plus 433 over 1376 minus 974 over 1376. So when I add and then subtract, I end up with 108 over 1376. And using my calculator, this does reduce, not required, but I do also get 27 over 344. So either of those answers would be acceptable for the probability that a student participates in both sports and music. So you can see that this equation is extremely helpful because I can solve for any of the four unknowns in the equation. In the last example, number 5, it says in a company 43% of the employees have access to a fax machine. So again, as I read, I'm going to write down what I know. So the probability that an employee has access to a fax machine will be 0.43. I'll do this one as a decimal. Notice that I don't have a total number of employees, so that's why I'm just using the percent as my probability. 38% have access to a fax machine and a scanner. So the probability of fax and scanner, that's going to be equal to 0.38. And 24% have access to neither a fax machine nor a scanner. So for that one, we're going to say that the probability of neither is equal to 0.24. We want to calculate the probability that the randomly selected employee will have access to a scanner. So what we are missing is the probability of just the scanner. Now when I see that probability of neither, that again is going to be the complement. So very much like example number 3. So the probability of neither being 0.24 leads me to believe that the probability of a fax machine or a scanner would be equal to 1 minus 0.24. Those are complements of each other. So that's giving me 0.76. Now let's set up my equation. So the equation for this one would look like this. The probability of having a fax or a scanner would be equal to the probability of a fax plus the probability of a scanner minus the probability of having both a fax and a scanner. So we know the probability of F or S. That's going to be 0.76. The probability of a fax, that's 0.43. We don't know the probability of a scanner. That's what we're solving for in this problem. So I'm going to say plus the probability of a scanner minus the probability of both. We know that the probability of both is going to be 0.38. So again, just mathematically solve for the P of S. So I'm going to take this term and subtract from both sides, and this term and add to both sides. So that tells me that the probability of a scanner will be equal to 0.76 minus 0.43 plus 0.38. And adding all of those numbers together, I get that the probability of having a scanner is going to be 0.71. So a 71% chance of having a scanner. This equation is very useful when we're calculating probabilities, especially when these probabilities could possibly have intersections. So think about what we did yesterday with Venn diagrams, and we combined it today with this new formula, and in either case we can come up with a probability of any of the missing pieces by using either our Venn diagram or by using this formula that we introduced today. Thanks very much. Have a great night, and we'll see you next time. Bye-bye.